Welcome to the first lecture for differential equation, and we're gonna do today about the introduction parts of differential equation, which contain type of differential equation, definition of differential equation, linearity property, degree and order of differential equation, and lastly dependent and independent variables for differential equation. And let's start. The first things, what is differential equation? Yes, this is course, but what's the meaning of differential equation, and what's the difference between differential equation and the normal equation? The differential equation is the equation which contains type of derivative. If an equation contains any derivative, we say this is differential equation. For example, 2x plus y prime equal 5. Are there any derivatives here? Yes, we have derivatives. That's why this is differential equation. But 3x squared plus y squared equal 1. Are there any derivative here? No, there is no derivative. That's why this is not differential equation. First things, it's gonna be like that. 2x dy over dx equals 0. So here there exists derivative. That's why we say this is differential equation. If an equation contains derivative, simply we say this is differential equation. In the differential equation, we have two type variable, dependent and independent variable. As shape in the derivative, if you check the denominator parts, gives us independent variable, numerator parts gives us dependent variable. Yes, this is as shape, but in mathematics, as logical, what is the meaning of dependent variable and independent variable in the derivative? Dependent variable, the variable that we are taking derivative of it. For example, dy over dx. We are taking derivative of y. That's why this is dependent variable. This is dependent variable. What is independent variable? The variable that we are taking derivative with respect to. This is independent variable. That's why x is independent variable. So don't forget the variable that we are taking derivative with respect to independent, and the variable that we are taking derivative of it, this is dependent variable. As shape, denominator independent, numerator dependent variable. An equation contains derivative. This is partial. This is differential equation. So now let's learn what's the order and degree. Yes, challenge, order and degree. Let's see what's the meaning of order and degree. They are like same, but in fact they are totally different. The order is the highest order of derivative in differential equation. The highest order of derivative gives us order, but the degree totally different. So let's see. And the notes for you, this is important. The common mistake that you are making always that I am seeing in the lecture. So note, what's the difference between these two expressions before doing degree and order? What's the difference? Here, which one have as order 2? This or this one? The order is related to directly d, differential d. So you have to check the power of d, okay? The power of d gives us order because it's related to times of derivative, number of derivatives. D squared, this is second order, but here D1, this is first order. Here 2 just power, this is degree, not order. Be careful about this part, okay? Don't be confused about power and order. D squared, D cubed, D to the power of 4 gives us order. Order here 1 and the power 2. So let's see what's order, the highest order of derivative. For example A, d cubed y dx cubed plus 2 dy over dx equals 0. Highest order. What's the highest order here? The order is 3. here is order is 1. What's the highest order? Order here, highest order equal 3. What is degree? Degree is the power of the expression that we obtained order. Where we obtained order? We obtained order here. What's the power of this part? Not order. Power of this part means bracket to the power of 1 here. That's why here degree is 1. The other example, let's see. B, d squared y dx cubed d squared to the power of 4 plus dy over dx to the power of 6 equal 1. Be careful. First, please let me know what is order here. Order is related to d. D squared. Here order is 2. D to the power of 1, order is 1 here, not 6, 4. 6 and 4 is power, not order. Be careful about that. So order 2 and 1. What's the highest order? 2. That's why order of this differential equation is 2. This is important. Where we obtain order? We obtain order here. So what's the degree? Degree is the power of the parts that we obtain order. What's power here? 4, and degree is 4. Don't be confused. I am not saying degree is the highest power. No. Order means the highest order of derivative, yes, but degree is not related to highest. Degree is the power of the expression that we obtain order. We obtain order here, not here. Don't say it is 6. We obtain order here. We got order from this expression because this is highest order. That's why the degree of the power of this expression is 4. Degree is 4. So be careful about the difference between order and degree. Order is the highest derivative which is related to d, and degree is the power of the expression that we obtain order parts. Be careful about it. This is order and degree. And the other things, type of differential equation. We have two type differential equation. The first one are ordinary, and the second one partial derivative. What's the difference between? Yes, in the differential equation we have derivative, of course. If we have derivative of variable, in differential equation. With respect to just one single variable, it is ordinary. But if we have derivative of the some variable with respect to more than one, that is at least two variable, partial. Just one variable, this is ordinary. But it must be same derivative of the same variable with the same variable. Look, same variable with respect to single, ordinary. With respect to at least two variable, this is partial. It must be same variable, okay? Be careful about it. Look, dy over dx, just one type derivative we have with respect to one type single variable. That's why this is ordinary. Z with respect to y, with respect to x. Z with respect to more than one variable, two variable. That's why this is partial. Here, are there any other information? Just y double prime. Are there any information that we have another type derivative? No. We have no any other information. That's why this is just a derivative. There is no information that we have another type derivative. It means just we have one type derivative. If we have one type derivative, this is ordinary. So be careful about this part. How many variables that we have as with respect, we are taking derivative with respect to xp, and we say yes, this is partial. No, this is not partial. Be careful. This is not partial. What we say, derivative of the independent variable, same variable with respect to one variable or with respect to more than one variable. Y with respect to x. Are there any y with respect to another variable? No. Variable with respect to single. For y, there is no other. That's why this is ordinary. For s, with respect to p, are there any other s with respect to another variable? No, there is no. S with respect to single, Y with respect to single. So all of them single variable for us under derivative. That's why this is ordinary. Be careful about part B. Don't check denominator. So I check denominator. According to denominator, this is partial because we have more than one variable. No, same variable with respect to single or more than one variable. You have to check this one. And this is ordinary and partial differential equation. The last part for introduction is linearity property. What is the meaning of linearity property? How can we understand if an equation is linear or not for differential equation? Let's see, and this is important for us as well. And the general nth order of linear differential equation can be written in this form. But if you see on the book somewhere, how can you understand this is linearity? What's the meaning of this part? I will give 3 hints to you. Okay, this is important. The first things, if you check the first things, all powers of derivative, powers of derivative, all of them just 1. You cannot see dy over dx cubed square something like that. All power of derivative just 1. No dy over dx cubed square to the power of 4 or minus 1 something like that. This is the first thing. The second things, check the coefficient. Coefficient, look, x, coefficient x, coefficient x, coefficient x. All coefficient have no dependent variable. This is important. Look, what is dependent variable? This is y. Dependent variable, we say in numerator, the variable that we are taking derivative, this is dependent variable. On the coefficient, there will be no dependent variable. If it is y, no y, no y, no y, and no y. In coefficient, just we have independent variable. And the third things, the things that I can say to you, the third one, if the dependent variable is y, here y, you will just see y, not y square, y cube. There will be no, look, the dependent variable y. You will not see y cubed, y to the power of 4, something like that, y to the power of minus 1, ln y, exponential y, sine y. Any function which is related to y, you cannot see. Just if it is y, just y. So this is the third things, you cannot see this type function. Okay, so let's start. What we say, powers for derivative 1. In the coefficient, there will be no dependent variable, and about the dependent variable, you cannot see any other type function. This is important. Let's start. This is linear or not. The powers of derivative, this is 1. Powers of derivative 1. So the first condition is okay. And the second condition, coefficient have no dependent variable. Dependent variable here y. Let's check in the coefficient, are there any dependent variable? No. No dependent and no dependent. The second one is okay. The third one, there will be no any other function for dependent variable. This is y, dependent variable. We have just y, there is no another type function. So the third condition is okay. This is linear equation. Here check the powers of derivative 1 on the coefficient. On the coefficient, there is no term of y that is dependent variable here, but about dependent variable, that is y, there will be no another function y, but we have exponential y. You cannot see any other type function which depends on dependent variable. There is exponential y. Because of third condition, this is problem, and this is not linear for us. And to continue, look, from second property, this is dependent variable. What second property says to us? On the coefficient, there will be no dependent variable. On the coefficient, we have dependent variable. This is problem for us. That's why this is not linear. And the power is 1, no problem. About dependent variable, there is no another function y. It's okay, but the second condition is not satisfied. Here, look, the first condition, what we say, powers of derivative must be 1, but powers of derivative here is not 1. This is squared, cannot be. You cannot write this type expression for linear equation, so this is not linear. By the way, don't think about xy always. It could be rs, p, any variable. So here, rs, what is dependent variable? Dependent variable, by the way, r. Instead of y, dependent variable r. So powers of derivative, are there any powers here which different from 1? No. This is 1, this is 1. First condition, okay. Coefficient have no dependent variable. Dependent variable r. Let's check, are there any r? No. There is no r. Yes. So coefficient part is okay for us. And the third things, coefficient, what's dependent variable? R, and we just see r. Let's check r. And the third one is okay, there is no r square and any function which is related to r. No, just r. That's why this is linear as well. This is important. And the last things, let's check what is dependent variable here. Dependent variable, not y. This is z. So power 1 and the power 1. The first condition is okay. The second condition, coefficient have no dependent variable. But look here, the dependent variable is z, not y. Are there any z? No. Not z, so the second condition is okay. Dependent variable is z, so we have to check z. Here, are there any other z? This is z. There is no another type function, so it's okay. This is again linear equation. So you have to check for linearity what is dependent variable. The most important thing for us, dependent variable and the power of derivatives. So this is the last parts for introduction, and the next video will be related to solution of differential equation, and don't forget to study.